Good day, everyone. My name is Abraham, and welcome to my Dynamic Maths channel, where we learn about mathematics. In this video, we will be answering a few questions regarding circular measures. I have created a video discussing about the basics of circular measure, and if you are still unsure on how it works, I highly recommend to watch that video first prior to this one. The link is given in the description below. If you have watched it or have learned about circular measures, great! Let's get started. There will be a bonus nature video at the end of this session, so stay tuned. In the first question, COB is a sector of a circle. We have two sub-questions, which is to find angle COA and perimeter CAB. Let's focus on the first sub-question. 14 centimeters is the radius and 6.4 centimeter is the arc length. Based on these two values, we can calculate the angle of COA by using the arc length formula, which is S equals R theta. Caution is needed here as the unit of theta is in radians, not degrees. We compute theta by substituting the values of S and R into the equation, and we will get this form. Solving it will give theta as 0.54571 radians. This angle theta is the angle for COA. The first sub-question is completed. For the second part, we need to obtain the length CA and AB. Because the parameter ABC requires us to add the lengths of AB, BC, and CA. The arc BC is given to us and we can ignore it for now. To get AB, we can subtract OA from OB. We get OA by using the cosine rule, as OAC is a right angle triangle. Then we solve for AB. First write down the formula. We will get 12.56 centimeters. But we need to get AB. AB is 14 minus 12.56. OB minus OA. OB is 14 because it is the radius of a sector of a circle. AB will be 1.44 centimeters. To calculate CA, we can use the sine rule to solve it. CA is 14 times sine of the same angle. Mind you, the angle is in radians, not degrees. CA is 6.18 centimeters. Now that we have AB and CA, we can now calculate perimeter ABC. Adding all together will give us 14.02 centimeters. We have successfully completed this question. In the second question, we have two circles with radii 5 cm and 10 centimeters. They both touch each other at point E. We have to find theta, minor arc EC, and the area of the shaded region. Let's answer the first sub-question. We can create a right angle triangle in the trapezium AEBDC. The short side is 10 centimeters. The short side is 10 centimeters, and the hypotenuse is the sum of the radius, which is 20 centimeters. Then we use the inverse cosine rule to solve for theta. Which is 60 degrees, or pi over 3 radians. In the second sub-question, we need to obtain the minus CAE angle and use the arc length formula S equals R theta. Angle CAE can be obtained by the total angle of the trapezium, which is 360 degrees. Angle CAE equals 360 degrees minus 90 plus 90 plus theta, which is 60. You'll get 120 degrees, or 2 pi over 3 radians. Then by using the arc length formula, we will get 10.47 centimeters. We have completed the second sub-question. In the third sub-question, we had to solve for the shaded area CED. We can obtain this by subtracting sector area AEC and BED from the area of the trapezium. To get the horizontal distance of the trapezium, we can use the sine formula on the triangle from part 1. Which is 20 sine 60, which will give us 17.32 centimeters. Then we compute the area of the trapezium, the sector area AEC and BED. The area of the trapezium is 1/2 5 plus 15 times the horizontal distance, 17.32. You will get 173.2 centimeter square. The next is angle BED. Sorry, let's start with the small one. AEC. We have 120 degrees over 360 degrees for a circle, because a sector of an area is a part of a circle, times the area of the circle, which is 26.18 centimeters square. Then area BED, using the same concept, (60 degrees over 360) times pi 15 square. You will get 117.8 centimeter square. Then you will calculate the area of CED, which is the area of a trapezium minus the area of the sectors. You will get 29.22 centimeters squared. We have solved the third sub-question, and with it, the second question. Thank you for sticking until the end of the video. I hope that you learned a little bit more on circular measures. If you found this video useful, please give it a like and subscribe to my channel. As promised, here's a nature video for you to enjoy. See you in the next video.